Hello all, what you see in the image here is basically a simple battery power bank circuit. So this could be told a very basic circuit, and there are many modifications that are required for the circuit, but to understand the operation, this is the circuit which can be used. So what you see here on the left is a 9-volt battery. Here we have just shown for indicative purpose a non-rechargeable battery, and which is providing an input to 7805 regulator. Now the functionality of 7805 we know, right? It's a fixed 5 volts output. So this takes 9 volts and then there is a 5 volt output, and this 5 volts is given to the USB power pin, USB type A female connector power pin. So if you see the available battery power banks in the market, so on the right you see two models here, and you can see the type A female connectors here, and also the bottom charger circuit which is available over Amazon for you to buy is a very simple one. You can see a type A female where you can plug in here, and then you can see the battery B plus. So the battery can be connected externally, whatever the battery we are talking here. So that's how the simple circuit is. And then USB type A female connector or any USB connector, USB 2.0 we should say, has power pin, ground pin, and also data pins, right? D plus and D minus. So D plus and D minus can be left open, can be terminated as we show here with the 200 ohms, and it can also be actively terminated to determine the type of charger it is. So there are several chargers as well, which we call them universal chargers, which use those kind of mechanisms. So very simple one. And then the one we show here is a very simple one where there isn't a rechargeable battery on the left. This is just a normal battery which is non-rechargeable, and then we have shown it for representative purpose here, whereas this will be in reality a rechargeable battery. And then this rechargeable battery should be charged through an external means. So if you see this bottom circuit here, there is an USB micro connector at the bottom. So this connector which is seen in our mobile phones is the same one which is used here, and then this will take the power from the USB cable, and then it will be charging the battery that is connected over B plus. So that is an additional circuit. So that is again an additional means which we have not represented in this simple circuit here. Now consolidating all these, what we can say is basically along with this simple basic circuitry, you should have a rechargeable circuit, and then there should be some protection means. If you see here, this is a bare minimum circuit that is represented here for the 7805 circuit, and then there is an input capacitor that is required, capacitor that is required at the input, and also there is a capacitor that is required at the output on the input pin as well as the output pin, which again depends on how long the battery is from the 7805 and how long this particular connector is. So there are several calculations that need to be done, and when you plug in some circuit at this USB type A connector, it will draw some current, right? 7805 LM7805 is a regulator which can provide a maximum of 1.5 amps output, whereas your charging needs, depending on the circuitry you are charging, might not require 1.5 amps always. You might need 500 milliamps, sometimes you might need 1 amp. So this, when depending on the load, it can provide a maximum of up to 1.5 amps. 7805 internally has the current limiting, but that current limiting comes into picture only when its maximum current is exceeded. That means 1.5 amp is exceeded. That means when you connect a load on this USB connector beyond 1.5 amps. But if you want current to be limited to 500 milliamps itself, and by mistake if we connect a load which is beyond that, then you should cut off the voltage to the load that is connected. So for that purpose, current limiting circuitry is required. And then as 7805 has this over temperature cutoff capability, that which we call thermal shutdown in normal embedded electronics, that in addition to that, we can have temperature sensors on the board. And as we mentioned, additionally the D plus and D minus lines, which can be left open or which can be terminated based on the need. So the charging circuitry, if you see a simple charging circuitry, it can be as small as this without a battery. So if you can imagine now, looking at the circuitry on the right side, it is basically the battery, the lithium ion batteries which we use in our regular applications, with that which occupy the more space. So on the top, if you see this battery bank, the actual circuitry which is involved, which facilitates the connectivity, the control and all, would be very less, but mostly the battery would occupy a lot of data. And then the harness that is there, which connects in different sections. So a very simple circuit. And then additional add-ons would be having an LED here to see if there is a supply from the battery or not, and then also a LED at the 5 volts output to see if 7805 is generating the required 5 volts or not. These are all visually enabling techniques or helps in visual debugging. So when you immediately power on the circuit, you just get this LED on, and you know that yes, the circuit is proper. If one among these LEDs is off, that meant there is an issue with either of these components. So a simple circuit which can be explained in a broader way, which can be expanded to an actual application. Please post your comments. Please post any innovative technologies that are coming up in the charging platforms in the comments below. Please like our video, subscribe our channel. Thank you.